The rate at which water flows out of the pipe is given by that function. Use the trapezoid rule with 6 subdivisions of equal length to approximate the integral from 0 to 24 of r of t dt. Explain the meaning of your answer in terms of water flow using correct units. So, trapezoid rule is pretty straightforward. Even if I have no idea what it's saying, I can probably piece my way through that, right? 6 subintervals is nice because that's how many they gave me, right? And it is even nice they did give me on this one equal subintervals. We're going to see that we're going out by 4 every time. So I can do 1/2 times 4 times 9.6 plus 10.3 plus, so that's my first trapezoid. Second trapezoid, 10.3 plus 10.9. And if you are good at these trapezoids and you want to do 2 times all the middle ones, you can do that. That's wonderful. If you're not good at them, just write it all down. 10.9 and 11.1. I'm switching colors on each trapezoid. Does that help? For you all to see where I'm getting the information. Plus 10.9 plus go black again. 10.9 and 10.5 plus 10.5 and 9.6. Does that look good? Okay. I expect that this is probably a calculator problem. I could be wrong about that. If it's not a calculator problem, you leave that nasty thing as your answer. It's nasty, but you'd leave it. If it's a calculator problem, go ahead and find the value. And does anyone know what that is? 253.2. So the integral from 0 to 24 of r of t dt is approximately 253.2. Why do I say approximately? It's trapezoids. Trapezoids aren't exact. Those are always approximate. Units. Well, if r of t is gallons per hour and t is in hours, so let's just draw a rectangle for a second. If the base is measured in gallons per hour is measured in hours and the height is measured in gallons per hour, what happens when I multiply? The hours cancel and I just get gallons. That's huge for answering this question. Does everyone agree? Just knowing the units is huge. So what do you think that means in terms of water flowing out of the pipe? What is that? The amount of water that flowed out of the pipe when? Good. I'm going to put from t equals 0 to 24. The reason I'm going to do that is that in any 24-hour period? It's in that 24-hour period. The way you could say that in words is the first 24 hours. But be careful, don't just say in 24 hours. Say in the first 24 hours or from time 0 to time 24. Yes. Yep, that's right. If it's non-calculator. If it's calculator, go ahead and put the value because it'll just help your brain out a little. But if it's non-calculator, I would agree with that. Okay, part B. Is there some time between 0 and 24 such that r prime of t equals 0? What do you think? maybe. It doesn't ask me to find it. It just says, is there? How do you know? Mean value theorem. Use a theorem. Don't just say because, don't just guess it. Why? Mean value theorem or Rolle's theorem would work great. Well, why? Right? So, how many of you remember Rolle's theorem? All right, we'll use mean value. I made you remember mean value. So, the first thing I need to do is, can I even use mean value? Well, let's go find out. What do I need to be able to use mean value? Continuous and differentiable. And remember, differentiability implies continuity, and it says R of t, the rate at which the water flows out, is differentiable. So I'm going to say R of t is continuous and differentiable. And I'm going to say R of 24 minus R of 0 over 24 minus 0. What am I writing down almost word for word except with numbers plugged in? The mean value theorem. You see why I made you memorize it. You need to know it. It is 0. You could show the work. You could do 9.6 minus 9.6, but they know that you know how to do computation. You just say that equals 0. Therefore, by the mean value theorem, there exists a C between 0 and 24. I am using mathematical notation here. Can you use words? Absolutely. I'm lazy, but if you would rather write that out, that's fine. Such that R prime of C is 0. So, I made the statement about it being continuous and differentiable because I have to be able to use mean value. I use the mean value formula and then use that to conclude something about a mean value. Okay, today we're going to learn the second part of the fundamental theorem of calculus. Remember, there is no rhyme or reason to why they're called first and second part, which one's which. In fact, a different textbook would call a different one the first one and a different one the second one. Do not write anything on this slide down. It is the proof behind the second part of the fundamental theorem of calculus. You don't need to know it. You don't need to do it. I just want to show you where it comes from. So this is more just for fun. Sure. So, if we have f that's the indefinite integral of little f, which is new to you, but something you need to know. Notationally speaking, you know how we call a derivative f prime? Every textbook will call an antiderivative capital F. So they will use the antiderivative as capital F to stand for the antiderivative of little f. So mental note that. You've actually seen that before. There's been a couple worksheets where I've labeled things as the antiderivative. You just didn't know what it was. So then we're going to define a of x to be an integral defined function from a to x of f of t dt. And then it says by part 2 of the fundamental theorem, a is also an indefinite integral of f. So they are calling part 2 what we learned yesterday. So that's what I meant by you could call them either way. Okay. There is a constant c such that f of x equals a of x plus c. What that means is any antiderivative of little f could be this, is going to be the same except maybe differing by a constant. So like the antiderivative of x is 1/2 x squared, but it could be 1/2 x. Okay, so we have 1/2 x squared plus 5 or 1/2 x squared. those are the antiderivative of the same function, but one has constant, one doesn't. So we're saying f of x and a of x differ by a constant. If we substitute a in f of x, in capital F of x, then that equals a of a plus c, which is the integral from a to a of f of t dt. What do we know about the integral from a to a of anything? That equals 0. So f of a would be the constant c. They're telling you why, which you knew that already. F of b would be a of b plus c. And so we would get the integral from a to b of f of t dt plus c. Well, rearranging what we know from f of a, because we said c was f of a, remember us saying f of a equaled c? Then we could say that equaled the integral from a to b of f of t dt plus f of a. Doing some clever substitution and rewriting, we get the second part of the fundamental theorem of calculus. This one is important because it gives us a way to find an integral with limits on it. Well, what's that mean? That actually gives us a way to find the useful part of integration for you right now, and that's exact area under a curve. So that brings us to the second part of the fundamental theorem of calculus. How to find the exact area under a curve. Now this is labeled differently than the last one. They use capital F and regular F. Notice this used F prime and regular F. Are those two things the same? They're both antiderivatives, right? This one labeled little f as a derivative to begin with, so then they used little f on the last, let me go back to it, they used regular f of t here in capital, f of b, f of a, but by definition, those are the same thing. So f needs to be continuous. Remember we talked about we have to have a continuous function to be able to find exact area. We have to have continuity. It is a BC calculus topic if we do not have continuity, or a Cal 2 topic if we don't have a continuous function. So, essentially what I can do is the antiderivative evaluated at the top limit minus the antiderivative evaluated at the bottom limit, and that gives me exact area. So, remember how hard it was to even get an approximation, a good approximation, like 10 rectangles, and how long that took us? We're about to take that down to 2 calculations. F of b minus f of a. And that will give us the exact area under a curve. So, example. The important part of the day, right? What are we doing on homework? You probably noticed this looks like your homework, right? First thing I need to find is the antiderivative, because I need to find the antiderivative at a, and I need to find the antiderivative at b, so I need to find the antiderivative first. So what is the antiderivative of sine of x? Y negative cosine. Right, the derivative of negative cosine is negative sine of x, which is positive sine of x. Remember, undo the derivative. I'm going to put a little bar here. That stands for evaluated at 0 to pi. So I'm going to evaluate it at pi, I'm going to evaluate it at 0. Essentially, I'm taking my limits and moving them over to this notation. So, the exact area is negative cosine of pi minus negative cosine of 0. When you minus a negative, what do you get? Positive. What's cosine of pi? Unit circle. Negative 1. So I have negative negative 1, which is positive 1. And what is the cosine of 0? 1. So the exact area under sine of x from 0 to pi is 2 units. If you don't believe me, get your calculator out. Go to alpha window, am I right? F int. Do the integral in your calculator. The calculator does need to be in radians, as always. What do you get?
You put sine of x or negative cosine?
Sine of x, because it will just give you the answer. Do what?
What do you need to do it by hand?
This will be on my calculator for the AP exam every time.
Do they get like easy ones or hard ones?
Some of both. Some of both. Do what? It does get easy.
Yesterday we found the answer, which was the antiderivative, and they added a plus c.
Good question. Why don't we need a plus c? And I meant to answer that and I forgot, so I'm glad you asked. If I did, do you say that?
I was just going to say, is it because like your answer is a constant?
Say that louder, Jameen.
Because
Good. If you were to put a plus c, and then you immediately went and subtracted two things with the same plus c, what's going to happen to that c? It's going to disappear in the subtraction. So because of that, it's not written down. Technically, it is still there, but for what are called, and by the way, a new word, these are called definite integrals. We learned yesterday we were doing what are called indefinite integrals. We didn't have definite endpoints. They were called indefinite integrals. For a definite integral, you don't have to do a plus c. It's not because it doesn't exist, it's just because it subtracts out. So very good question.
So, say there was a question on the exam that we got yesterday. It would just ask what the antiderivative.
It would write this question without the 0 and the pi.
But I'm saying, like, if they gave you a question, they would give you, like, something from yesterday and say, find the antiderivative.
No, they would give you, so on the AP exam from yesterday, it would look like, if they wanted you to answer what we did yesterday, it would look like this.
The differences between the numbers.
It doesn't have the limits on the ends.
But will they say find the antiderivative?
Probably not.
Okay, so you kind of just have to.
You have to know that the integral is the antiderivative.
And then, so
Now, I'm saying no. Now, is there some problem out there that uses the word antiderivative? Maybe, but typically they'll be more like that.
And then if it's a question like today, it'll have the endpoints.
That's right.
Okay.
Okay, let's look at the next one. Step 1, I need the antiderivative. I have x squared plus 2. What is the antiderivative of x squared plus 2? Good, 1/3 x cubed. There's a rule for that, Scott. You add 1 to the power and divide by the new power. Why? Well, we're undoing derivatives where you subtract 1 from the power and multiply. So, add 1 to the power, divide by the new power. Check it. Does it work? 3 times 1/3? Subtract 1. Do I get x squared? What is the antiderivative of 2? Good. From 0 to 3. On multiple choice, will you have to do this without a calculator? Yes. So, yes, you do need to be able to do 3 cubed. Yes.
On like the very first homework you gave us, or like finding the answer of like one of these or whatever, and you take, I don't know, I guess I'm confused on like how do you know what that you need to find the antiderivative of this for one, like if you find the area of the other one.
Good question. So we didn't know that, and it's not an obvious conclusion. It's not not something that you just go, well, duh, area is antiderivative. That doesn't make sense, right? So remember, it took Isaac Newton a very long time to figure this out. But we just figured out that it just turns out that the area, the integral, which is defined to be area, and yesterday we talked about it being area. Remember, we looked at that curve of the area? It just happens to be the antiderivative at b minus the antiderivative at a. So it turns out we're kind of doing a shortcut. The long way to find area is infinitely many rectangles. Yuck, right? And so we just found out that, hey, this is faster and easier, and it gives me area too. It may not feel faster and easier yet, but would you agree this is faster and easier than even 10 rectangles? So it's kind of like we've found ourselves a shortcut for area. That makes sense. Okay. 3 cubed is 27. 27 divided by 3 is 9. 9 plus 6, that's the first part. I know it's silly for me to write it down, but I'm going to do it. What am I going to do second after I plug in the 3? Plug in the 0. It is 0. I know it's silly to write minus 0, but for note-taking purposes, I am plugging both in. So 15. So the exact area under the parabola x squared plus 2 from 0 to 3 is 15 units.
So I kind of depends on the question, because like I feel like that kind would be easier to do it the first way before we learn this, because you would just like find what's in between the 0 and 3 and plug that in and then add it, right?
Well, but remember, if you did Riemann sums, if you only did 3 rectangles, you're not getting 15. You would get an approximation.
But if you plug in 3 for like the x squared, and that's 9, and then you do the 3 times 2 because that's a rectangle, then you get 15. Is that just a coincidence?
Yes.
I guess I'm.
So to get exact area with Riemann sums, you'd have to do lots and lots of rectangles, and you'd have to start eliminating you'd have to do lots of right rectangles. So before this existed, and we actually never did this because it would be miserable, but before Isaac Newton came up with this, to find area under a curve, they would do right rectangles, they would do left rectangles, they would do lots of both, and start eliminating their error to get closer and closer, limiting that process to find out what the exact area was just by doing more and more rectangles. I don't want to do that. You don't want to either. If you didn't know the answer was 15, it'd take you a while to get there. Okay, the next one. What is the antiderivative of e to the x? And remember, constants just hang out. So 4e to the x, that's a property of integrals from 0 to e. Is that what that says? Yeah, 0 to e. 4e to the e minus 4e to the 0. What's anything to the 0 power? 1. So this is 4e to the e minus 4. That's nasty, but that's the exact area. Now you could, of course, get a decimal value for that if you wanted to. Question. Will your calculator give you that answer? No. It'll give you the decimal, right? So you could check in your calculator. You could not answer that one in your calculator, though, for homework purposes. Okay, what about the next one? What is the antiderivative of 5 over x? 5, natural log, the absolute value of x. Evaluated from 1 to e cubed. So I get 5 natural log of e cubed minus 5 natural log of 1. What's the natural log of e cubed? 3. How do you know it's 3? Good. So that's 15. What's the natural log of 1? I bet that was on a mastery exam at some point, wasn't it? So 15 is the exact area under that curve. Okay, now we're going to do a couple of AP style problems. Some different ways AP can throw some things in. Find the value of k if the integral from 0 to k of 1/4 x cubed dx is 16. Any ideas? Okay, work the integral on the left. Yeah, like set it up, do the integral. What is the antiderivative of 1/4 x cubed? Yes, does everyone agree? I'm going to evaluate that from 0 to k. Everyone agree? So at k, wouldn't that just be 1/16 k to the 4th? Whatever that is. It's minus 0. And it says that equals 16, right? And what was the question? What is k? Well, k to the 4th is 16 times 16. If you know that, you can write it down, or you could leave it as 16 times 16. Since I'm about to 4th root it, it might even help to leave it as 16 times 16. It is 256, but what to do? What is the 4th root of 16 times 16?
Well, we have a calculator for this.
I don't.
2 would be 4.
Why 4?
Because you just square both of those.
Okay, let's go back to Algebra 2, how we do 4th roots, right? This is pretty elementary here, but it's okay to have to do stuff like that. Don't you normally do factor trees when you're doing 4th roots? I know it's 16 times 16, right? And 16 times 16 could be broken up into 4 times 4 times 4 times 4. There's 4 of those. So the 4th root of that is 4.
So if it's on an AP exam, there's no calculator, is it going to be something like that? So that's easier to see.
The numbers are always workable on non-calculator AP. Do you have to use 4th, 5th, 6th grade, 7th, 8th, 9th grade math? Yes. And that gets some people sometimes. You know, sometimes you'll have to multiply numbers. It won't kill you. Okay, the region bounded by the x-axis and part of the graph of cosine x between negative pi over 2 and pi over 2 is separated into 2 regions by the line x equals k. If the area for the region from negative pi to k is 3 times the area of the region from k to pi over 2, then what is k? Whoa, right? That's scary. So cosine looks like that. Oh, I am doing some AP problems. Not every AP problem is this hard. These are some tough ones that I've pulled in. Everyone agree cosine looks like that? Touches at negative pi over 2 and pi over 2. So I have some vertical line drawn through that. X equals k. Right? And I know that the area from negative, this part over here, is 3 times that part. Right? There's a lot of ways you can do this. Do you have any ideas? Before I do it, let me give you this homework. Finish the worksheet, and then some more book odd problems. Did y'all check those in the back of the book? Odds are in the back. There's a reason I'm assigning them. I want you to check them. Now, you'll have to do 30 on your very own. Okay. Yeah. Yes. And at the end of every video, you'll see that little flip too, where I'll show you what the homework is. Could I find the integral from negative pi over 2 all the way to pi over 2 of cosine of x? You actually need to do that work. I am going to cheat and tell you that answer's 2. Cheating. Okay, if that's 2, and this is 3 parts to 1 part, wouldn't you agree each part is a fourth, or a half, sorry? If it's 3 parts to 1 part, there's 2 units total, right? It's like a candy bar, we broke it up into 3 parts and 1 part. We have 2 units broken up into 3 parts and 1 part, so there's 4 parts. And so each part would be a half. So what I would do is the integral from k to pi over 2 of cosine of x equals a half. This becomes just like this problem up here. Does everyone see how that becomes just like that problem? But I had to do some work to get it there. I had to find the last one, just mental note. I have 2 different functions. So to find this area, I need to break it up into the integral from 0 to 1 of the square root of x plus the integral from 1 to, that says 2 down there if you can't see it, of x squared. Does everyone see how I got that? You have 2 different functions, do 2 different integrals.